के दर्शन के लिए अपने मित्रगणों के साथ सुबह सुबह हम लेते हैं चाय की चुस्की लेने के बाद हम देव प्रयाग हमारा वो स्थान है जहाँ पे माँ गंगा और माँ भागीरथी मिलकर गंगा नदी बनाती है। यहाँ पर एक आंटी मुझे स्नान कराती है, जबकि उनका मानना है कि यहाँ पे स्नान करने से आपके सारे पाप ठीक हो जाते हैं। तो मैंने किए थे बहुत सारे पाप, इसलिए मैं अलग से देता हूँ एक अपने लिए स्नान। और स्नान करने के बाद हम लोग भी काफी जोर शोर से तो यहाँ मैं अपने पेट को शांति देती हूँ, क्योंकि मुझे ग्रहण करने से मना करता है, क्योंकि उस वो फल लेके आया है तो बाबा की तरफ नहीं था। ये बात हरी देवी नहीं है, जबकि रुद्र प्रयाग में स्थित है। यहाँ पर चारों धाम की यात्रा शुरू करने से पहले सबसे पहले यहाँ जाया जाता है। यहाँ जाने से आपकी सारी मनोकामनाएं पूरी होती हैं। यहाँ मिलने का सरकार और यहाँ हम है लुप्त भी होती है और हम लोग को बैठते हैं गाड़ी में, किसी को आते हैं चिट्ठी, किसी को आते हैं रोटी को, किसी को आते हैं खाने। उसके बाद हम लोग करते हैं रुद्र प्रयाग के बाद विष्णु प्रयाग की यात्रा आगे भी बढ़ सकती है।
So very good afternoon to everyone. So I am Rohit Gehlot and I will be taking the week 11's theory of production processes courses tutorial. So today we will be solving some of the welding problems, and also I will be like clearing the doubts asked by the previous in the previous class for related to welding. So let's start. So today is like the first problem is this. So if a metal inert gas welding two stainless steel workpieces are joined with electrode diameter of 2.4 mm with a wire feed rate of this. With a wire feed rate of 3.2 mm meter per minute and total area of weld bead of this, and the welding speed used in the welding process will be. So like we did solve these type of problems in the previous class. So try solving this try solving this problem. After that I'll solve this. So let's solve this problem. So firstly we can find the melting rate of electrode. So this can be find out by As given in the problem, the electrode diameter is this and the wire feed rate of this. So from this we can calculate the melting rate of the electrode, or we can say mmq per minute. So this will be coming around 14476 mmq per minute. And then this melting rate of the electrode, this will be equal to filling rate of the weld bead. So we will equate this to area of the weld bead. Velocity of the welding. So from this we can find out the velocity is so here we will get in mm per minute, and we can convert it into mm per second by dividing it by 60. So that's how we can solve the first problem. So let's move to the another problem. So a 20 volt supply is used in a shielded arc welding operation on a carbon steel with electrodes of the same material. The cross-sectional area of the weld is this. The specific energy to melt a metal for carbon steel is 12.3 joule per mm cube. The welding speed is 10 mm per second. The efficiency of the heat input is 75%. The required current is. So this is also a very simple problem. So at equilibrium we can say that the heat input to the melt is equal to the electrical energy. So you can write it as heat input is equal to the electrical energy. And this will be equated as then from here we can find out the current as this will be coming as around 590. So the answer is. Let's move to the next problem. So the power source characteristics of a DC power source is given by this. The current for maximum power is. So the same types of problem we We did solve extensively in the last class, so we solved more than 10 problems around in the last class. So this is just a revision kind of thing. So the power source characteristics of DC power source is given by this. The current for maximum power is, so we know that power can be as P is equal to V into I, which is equal to, we can take common I into, so we just need to multiply this by I, so I square minus, so this is the power, so then we can write it as IQ minus then for maximum we will be equating it as dp by di is equal to 0, and then from here we can find out as 3I square minus 400 I minus 4 is equal to 0. And then we can use this Sridharacharya law and we can find out I. So this will be coming around 133 ampere. So by this we can solve the problem. So let's move to the next problem again. So this is problem number 25th. So in a projection welding, two projections are welded at a time with a secondary voltage of 2 volt. Assuming that the contact resistance of A for each projection, the rate of heat generated at the contact is, so for the there is written that for a secondary voltage, assuming the two projections are welded at a time, so the spot produced for these are the parallel welding, so we can do it like this. So this is R1 and this is R2. So for the parallel welding we can calculate it as this. And then we can solve it by 1 by 200 plus 1 by 200. From here we can calculate R is, and then the heat generated we can calculate it as, oh, this will be coming around 40 kilowatt. So now let's move to the doubts which previous the students asked. So this is the doubts, these are the doubts. The first one is the, what do you mean what do you meant by fusible flux that mentioned in the submerged arc welding? So the fusible flux is nothing but what we can say that this fuses with the your weld, so that's why the name fusible flux is being used. So thus it gets fused and melts with the melt. So, and second question is in the electroslag welding, it is said that the weld surface will be covered with the molten slag in it. So we don't need any electrode or filler material here. So we will be needing the electrodes. This is the basic diagram of the electroslag welding. So so it is a highly productive process, and it is like it welds in a single pass, and generally it is used for to weld high thickness for material like 25 to 300 mm, and generally it is used for vertical positions, and then it can weld low carbon steel easily with a DC voltage around 600 ampere and 40 to 50 volt is being used. So where were we? So we were so in the electrode it is said that so there is definitely the electrode is being used, and also in the electrode it is said that it will give the metal will solidify in contact with water. So actually when we are dipping weld in water, then it will be, so generally in electroslag welding we don't do this, like we're dipping in the water. I think some sub process after welding, some for some specific application they are doing it, they might be doing it. So that's why this may be the case generally, but generally we don't do this. But the rest thing which you have written, like will it lead to the breaking of weld or weakening of the weld? What is the actual property needed for the weld? Whether it should be hard or ductile? So generally, the weld should be strong enough, and also the like it is written that it will, yeah, if you will quench it, then definitely it will become bitter. Then let's move to the next problem. In cold welding, it is said the plastic deformation is the reason for the joining of the two surfaces. Is it like the atoms from one surface is going to other surface and vice versa? Does that mean the atom is okay? Where is it? Okay, where was I? What I was doing? Okay, is it like the atoms from one surface is going to the other surface and vice versa? So I prepared one. So this is how the process works. So whichever two surfaces are need to be welded, firstly the surface is being prepared, because if we talk about the cold welding or contact welding, it is a solid state welding process, and then the joining, here the joining takes place without fusion or heating at the interface, and then the energy for weld comes in the form of pressure. And when atoms in contact, someone like there is one, I copied it from some book, that when atoms in contact are all of same kind, there is no way for the atoms to know they are in difference. So like whenever the surfaces are, firstly the surfaces are being prepared, because to if some previously some oxides are present at the surface, so they are being cleaned so that the purely metallic surfaces are being present, and then a high amount of pressure is being applied to create the metallurgical bond, and then what happens is that the applied pressure brings the surfaces of the workpieces together as close as possible, and once pressed together the nanoscale distance becomes irrelevant and metal becomes jump from one piece to another. This results in a near perfect bond with almost no repercussions. And the two separate pieces of metal becomes a homogeneous mass. That's how the mechanism of the cold welding works. So yes, pressure brings them together. The atoms diffuse from one when the because surface. It's the same process happening in the ultrasonic welding. Here, yes, the same process happens in ultrasonic welding. Here also the plastic deformation. Yes, plastic deformation is the case. And how slag will help to control the heat transfer rate in the slag is nothing but a molten pool of oxides and sulfides. It's just the impurities. Generally, it is being removed so that the because they have the generally the higher temperature, higher melting temperature than comparison to the what we can say that compared to the noble metal, they have the higher melting point, so that's why they are being chipped off generally. Like you have already written, weld will also, the slag will be chipped off, because if they won't be chipped off, your surface finish will be very poor. So that's why it is very important to remove the slag. And besides that, it controls the heat transfer rate in the liquid metal in the weld pool, as that they have high melting point, so they generally absorb or like the hinder the heat transfer rate. Okay, so next question is, will the flux coating affect the viscosity and the surface tension of the molten metal? Yes, the flux coating, depending upon the flux material, your viscosity will be affected. Like flux, for example, flux are made from different material. Like if they have, like for example, if they have high silica content and they exhibit high viscosity due to the network formation tendency of the silica ion, and which needs to be controlled by addition of calcium fluoride, calcium oxide and magnesium oxide. So yes, the flux coating affects your viscosity as well as surface tension. In electroslag welding, do we use the flux as electro? No, as already previous question is to answer. Like the shielded metal welding, same question. Okay. Okay then, so these were the problems in question I wanted to cover in this class. Okay, then let's wrap up the session, and thank you for the class, and let's meet next week.